Hi guys. Today we're going to look at 3.6, which is some growth and decay problems. So before we get started, up at the top of your paper, I'm in my 3.6 notes, up at the top of the paper, I need you to write two things for me. I need you to write that, and I need you to write this. Now, as we go through the problems, I'm going to tell you which formula is appropriate, and I'll tell you what all the different letters in the formula mean. But we're going to do that one at a time as we go through the problems, okay? So, problem number one. How long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? That is the key. This is the formula we use. When we compound interest, this is only for money. This formula is only used for money, and we compound interest a certain number of times. This is the formula we use when we compound interest a certain number of times. So this is the formula I'm going to use for this problem. Okay, so I'm going to write down my formula. That's the one I'm using. In this formula, A is the ending amount. So as I read my problem, it says, I want my investment to double. Well, I'm starting with 1,000, so I'm going to end up with 2,000. If I want my investment to double. P is the starting amount. So that's 1,000. That's a 1. R is my interest rate. So what is it? 2.5%. Now, I have to put that in as a decimal. So 2.5%, move it two places, would be 0.025. So 0.025. N, and there are two of them. There's an N here and there's an N here. They're the same thing, and that is the number of times a year that I compound. This says I am compounding quarterly. So N is 4 times a year. So I put a 4 here and a 4 here. And then T is the number of years. So how many years is it? Oh, that's what I don't know. So that's my variable. How many years is it going to take? How long is it going to take to make this 1,000 grow into 2,000? Okay? So now I'm going to solve this. And it looks way more scarier than it needs to be. You do not need to be frightened by this. One thing you can do, if it makes it easier for you, is, well, I tell you what, let's do start. Let's divide both sides by 1,000, get rid of this extra number. So if I divide both sides by 1,000, then I'm going to have 2 equals 1 plus 0.025 over 4 to the 14th. One plus 0.025 divided by 4. And I don't know if this makes it better or worse. 1.00625. At least now we don't have a fraction to panic you. Now I need to solve that equation. whenever my variable is up as an exponent, whenever my variable is up here, I need logarithms. So I am going to take the logarithm of both sides. Now that leaves me with log 2. Now the exponent comes out in front. This is why we practiced all those problems. So now 4t log 1.00625. Now I need to solve, this is what I'm solving for. So I need to divide by everything else. I need to divide by 4, and I need to divide by log 1.00625. Now, I want you to do those two things separately. Okay, we clearly need to divide by both. And if you don't use parentheses properly, this can not be, you can end up wrong. So here's how I want you to type this in. Type log 2, close the parentheses, divided by 4. So we'll take care of the 4 first. Hit equals. Don't write it down. Then take that answer, divided by, just hit divided by, log 1.00625 equals. So when you type this in, do log 2 divided by 4 equals divided by log this. And the answer is 27.81 years. I'll round to the nearest hundredth. I don't think there's any instructions. So this time I'll just round to the nearest hundredth. So how long is it going to take? 27.81 years. Number 2, read the problem. You will notice when you read the problem that it says compounded monthly. We are going to use the same formula because this is the only formula we use if we are compounding a certain number of times. And if we're doing it monthly, we're doing it a certain number of times, 12 a year. So I'm using the same formula. How much will be in the account? In other words, how much am I going to end up with? I don't know. That's this. That's what I'm going to figure out. If I start with 1230, remember that's my starting amount, and my interest rate is 0.03125. One more time, 3.125, 2 places, 0.03125 is my interest rate, compounded monthly for 10 years. So my starting amount is 1230. That's a 1. My interest rate is 0.03125. N is 12, and T is 10 years. I always, if I can, I always take care of that. So 12 times 10 is 120. So I'm just going to write that as 120 to get started. Now, were you listening a minute ago when I said that when my exponent is the variable, when x or t or whatever is up here, then I have to use logarithms. Where is my variable this time? Boys and girls, this is just a plug-in problem. So I am literally going to type in exactly what I wrote. So I'm going to type 1230, I hope you're typing with me, parentheses, 1 plus 0.03125 divided by 12, close parentheses, raised, using your little caret button, raised to the 120th power. And hopefully you got $1,680.53. So again, I use logarithms in one case, and that is when the thing I'm looking for, my variable, is in the exponent spot. If my variable is anywhere else, I just crank it in. Just type it in. And if you type exactly what I wrote, you will get this answer. Now, I'm going to skip number 3 for a minute, because number 3 is not even about money. So number 3 will not use this formula. We'll come back and grab it. Number 4, how much money do I need to deposit 4% compounded continuously? Wait a minute. Again, that problem, number 4, is not this formula. Because this formula is compounded a certain number of times. So compounded monthly, compounded quarterly, compounded daily. Compounded continuously, I don't know what number is continuously. It isn't a number, it's infinity. So I'm going to skip that one for a minute. Number 5 is not about money. Skip it for a second. 6 is not about money. Skip it for a second. Number 7, how much will I have in my account after 12 years if I deposit $555 at an interest rate of 3.5% compounded monthly? That's when I use this formula, when it says compounded monthly, compounded quarterly, compounded weekly. That's when I use this formula. So number 7 is going to be this formula again. Okay, so here we go. How much will I have in the account? In other words, how much will I end up with if I deposit $555 at an interest rate of 0.035, compounded monthly for 12 years. Now, this 12 right here, look where I'm pointing. This 12 right here, these are the ends. That 12 is the compounded monthly 12. This 12 is the 12 years. They just happen to be the same number this time. Okay, I always do this first. 12 times 12, that's 144. Do I need logarithms to solve this equation? No, I do not. Because when do I need logarithms? When the exponent is the variable. It's not. So, another plug-in problem. Here we go. 555, parentheses, 1 plus 0.035 divided by 12, close parentheses, raised to the 144th. $844.17. And number 8, what interest rate compounded continuously? Stop right there. That is not this formula. This formula is only for problems that say compounded quarterly, compounded monthly, compounded weekly, compounded daily. That's what that formula is for. So I have now done every problem in this problem set that has to do with that formula. Okay, so now I'm moving on to the other formula. This formula is for this, remember, this one is only for money. Now, this one can be used for money if it's compounded continuously. So if you see that word, compounded continuously, then you're going to use that formula. You're also going to use this formula for non-money. So there's only two formulas you're responsible for. If it is money and it's compounded a certain number of times, then it's that one, the big one. If it's money but compounded continuously, it's what we call the PERT formula. If it's not money at all, then it's going to be PERT. So I'm going back to my problem set, my notes, and problem number 3 says it's not money. Problem number 3 is not money. It's about some organism called geosites. So I know I'm going to use this formula because it's not money. How long will it take for a population of 450 to double if their growth constant is 0.123? All right, so let's look at this formula. What do all the letters mean? Again, A is the end amount, and P is the start amount. Okay, whether it's money or organisms, whatever. A is what you end up with, P is what you start with. That's E. That's our number E, the base of the natural logarithms. That is not a variable. You're not going to plug anything in for it. That is Euler's constant. R is the growth constant. And T is the time. So when I look at problem 3, I am starting with 450 geosites. So P is 450. I want this population to double. So if I start with 450, how many am I ending with? 900. The growth constant is 0.123, because I don't need to change that. It's not given as a percentage. If it's given as a percentage, like 8%, you need to change that into a decimal. But this one is already a decimal, so it's perfect. And I want to know how long that's going to take. So T is my unknown. Look, I know everything else. Am I going to need logarithms? Yes, I am. Because where is my T? So I need logarithms. Before I do logarithms, though, I got to get rid of this 450. Again, we practiced equations like this, and I told you they were going to show up in our word problems, and here they are. We got to get rid of that 450. So I'm going to divide both sides by 450. Luckily, that's just 2 equals e to the 0.123t. We did a whole bunch of these last time, or actually 2 times ago maybe. How do I do this? I need to take the logarithm of both sides, but since my problem has an e in it, let's ln both sides. Physically write ln on both sides. What happens right here when you ln and e? Why, they cancel. So ln2 equals 0.123t. And t equals ln2 divided by 0.123. I go to my calculator, nothing hard about this one. Don't forget to close the parentheses though. ln2 divided by 0.123. How long is it going to take? Looks like it's going to take about 5.64 years. Okay, let's look at number 4. Now, we talked about it a little bit ago, but let's read it again and understand why we are using this formula. How much do I need to deposit in an account paying 4% interest compounded continuously? That's why I'm using this formula, because it says compounded continuously. So here we go. How much do I need to deposit? In other words, how much am I starting with? That's P. I don't know what it is. I'm going to figure it out. The interest is 0.04, so the growth constant, the growth rate of my money is 0.04. I want to end up with $35,000 in 10 years. So my ending amount is $35,000. I don't know my beginning amount. That's E. My interest rate is 4%, and I'm going to wait 10 years. Okay, so first thing I want you to do is multiply these. Go ahead, just like we did before. So that's going to be 0.4. So I have 35,000 equals something times e to the 0.4 power. Now, where is my variable? Is my variable in the exponent spot? No, in the exponent spot is 0.4. Do I need logarithms? No. If I want to know what p is, I am simply going to divide both sides by e to the 0.4. That's it. Nothing tricky about it. So 35,000 divided by second ln. When you press second ln, e comes up. And it literally says, what power do you want me to raise e to? 0.4. So you would have to deposit $23,461.20. So again, 35,000 divided by second ln 0.4 equals, and that is the number that you should come up with. Number 5. Find the decay constant of an element if its half-life is 10.2 years. Okay, you guys, now stop a second. Does this problem have anything to do with money? No. So it's not going to be that formula. You've only got 2 formulas to worry about, and it's not that one because that one's only money, so it must be this one. Here we go. Find the decay constant. So I am going to be finding R. So there's E. E never changes, so E's just E. That's my variable. 10.2 years. So my time is 10.2 years. The half-life Okay, now this is where you really have to rely on what you learned in like chemistry or something. What do we mean by half-life? We mean that we end up with, after that 10.2 years, we end up with half of what we started with. Now, did they tell me how much I started with? No, and it doesn't matter. Pick a number. So maybe I want to start with 100 grams. Okay, if I choose to start with 100 grams, then I'm going to start with 100. But then what would I end up with? Remember, it's half-life. So I'm going to end up with half of what I started with. Now, you're not in front of me, but I know what you're thinking. You're thinking, Miss Ford, you're just making up numbers. Yes, I can. So let's make up another one. Let's suppose, I chose to start with 100. What if you chose to start with, 30? Okay, if you started with 30, then you would have to end up with 15. Would you agree with me? It's half-life. Whatever number you choose to start with, and this is your starting amount, whatever you're starting with, you're going to end up with exactly half of it. Okay, so let's solve my equation first, and then we'll solve yours, okay? Is my variable in the exponent spot? Yes. So am I going to need to use logarithms? Yes. But before I do that, I've got to get rid of this number. So I'm going to divide those sides by 100. Would you agree that 50 over 100 is 0.5? And then I have e to the 10.2r power. Those are multiplied power. Now I'm going to ln both sides. That's going to go away. So I'm going to have ln 0.5 equal to 10.2r. I'll divide by 10.2. And r is going to be ln 0.5 close parentheses divided by 10.2. Negative 0.0680, basically. Now wait a minute. Negative. R is supposed to be the growth constant. How can that be negative? You're right. What's happening in this problem? This stuff isn't growing, this stuff is shrinking. So this is actually not a growth constant, it's a decay constant. Now we would never want that to happen with our bank money, obviously, but in this case, whatever this stuff is, it's decomposing. Every 10.2 years, I only have half of it left, and that is its decay constant. Perfect. Now, let's come over here and solve your equation. Remember, we were a little baffled and Miss Ford was just making up numbers. I said, I think I'll start with 100. But you said, I think I'll start with 30. Okay, we're going to solve your equation now. What's step one? Divide by 30. And what happens right here, guys? When you divide by 30, isn't that going to be 0.5? And aren't we going to end up with exactly the same equation? And you're going to ln both sides, and you're going to divide, and you're going to get the very same answer I did. So if I know I'm going to end up with half of what I start with, then it makes no difference what I start with. Cool. Okay, that was 5. All right, so now we're going to look at 6. how do I know that 6 is also this formula? Because 6 is not money. It's not money. So anything that's not money is going to be this formula. Okay? So here we go. How long will it take for 193 to grow into 391? Keep in mind, start, end. I'm starting with 193, ending with 391. Their growth constant is 0.222, and I want to know how long it's going to take. Notice where my variable is. It's up here. So if my variable is up there, I'm going to need to use logarithms. But what do I have to do first? First, I have to divide off that 193. That has to happen, kids. We talked about it for several days. That has to happen. So 391 over 193. Don't simplify that. Don't do anything with that. It's what it is. Equals e to the 0.222t. So what do I need to do? I'm solving for an exponent. I need logs. Since there's an e, let's ln. So ln 391 over 193, whatever that is, equals 0.222t. How do I get my answer? I'm going to divide by 0.222. So, ln 391 divided by 193, close parentheses, divided by 0.222. And t is going to be 3.18 years. Number 7, already did? Because number 7 said compounded monthly. That's this formula, compounded monthly. Number 8 says compounded continuously. Okay, compounded continuously. So here we go, compounded continuously. What interest rate will be required to end up with 1,000 if 890 is initially deposited for 3 years? So what interest rate, that's my unknown, I'm gonna wait 3 years. I'm going to start with 890 and end up with 1,000. Look where that variable is. Yep, it's right up there where I don't really want it, but that's where it is. So I'm going to need to use logarithms. But what am I going to do first? I'm going to divide by 890. So I have e to the 3r. Over here. And over here, you're certainly welcome to leave it as 1,000 over 890. You could cross off those zeros and have 100 over 89. You guys, it doesn't matter. Whatever works for you, whatever makes sense for you. It's okay to leave it 1,000 over 890. In a minute, we're going to type it in our calculator anyway. Since my variable is up here, I'm going to ln both sides. Those are going to cancel. And I'm going to have ln 100 over 89 or 1,000 over 890 equal to 3r. So then I'll divide by 3. ln 100 divided by 89, close parentheses, or 1,000 divided by 890, close parentheses, divided by 3. The interest rate, 0.0388, is the decimal. So the interest rate percentage would be 3.88%. That would be the percentage, the actual interest rate that's required. Okay? Great. Thank you. Hope you're having a great day.